So we have a technique to help us try to evaluate integrals that are otherwise like tough to imagine, because what you're doing is you're trying to think of a new function, or trying to think of a new function so that if you were to differentiate that function, it would turn back into this function. And so you can use your imagination a bit, try to picture what that function looks like, but oftentimes it gets really complicated because of the chain rule and the product rule with differentiation. So when we're trying to evaluate this antiderivative, they've given us a hint here. Just for other problems, if you don't have a hint, it's kind of like trial and error. You can just guess, like maybe I'll let u be cosine of theta. Then you have to check, what's your du going to be? What's the derivative of u with respect to theta? Well, the derivative of cosine theta with respect to theta is going to be negative sine theta. And I wouldn't have negative sine theta in here, right? So I've got nothing to substitute. So in that case, my choice of u does I don't have my du. I can't replace anything to make a du happen, so that the integral is with respect to u. So it really is just kind of a trial and error thing. Once you do lots of u substitutions, then you get an intuition for what to do. So this one's given us a hint. Excuse me. And this one, since we don't have that du, they've also given you the hint to help you find out, what it's going to take to have us get that du. They said use the fact that cosine squared theta is 1 minus sine squared theta. So here, this is cosine theta times cosine squared theta, right? That's the same thing. And I've expanded that. That way I can use the Pythagorean identities. We have that sine squared theta plus cosine squared theta equals 1. You can rearrange that identity to solve for cosine squared. Cosine squared theta is 1 minus sine squared theta. All right, so that's where they got that substitution from. So these identities here you're going to want to have in your back pocket. Sine squared plus cosine squared equals 1. You want to know that 1 plus tangent squared theta would equal secant squared theta. Well, kind of had a brain lapse there. Just have those Pythagorean identities in your mind, because those will often help us out with these integrals. Okay, so we've rewritten a bit. Let's see. I mean, we can use their hint. Let's see what that hint's going to do. We can rewrite this as 1 minus sine squared theta. So they want us to let u be sine theta. So if we let u be sine theta, then we need to have a du somewhere. And the derivative of sine theta, with respect to theta, is cosine theta. We have du. So that means we can now change the variable to something more simple. Okay, that's the big goal of u substitution, is you want to change the variable into something that's simpler. So if we go through and we make our replacements, 1 minus sine squared theta, that's now 1 minus u squared. And then it's now with respect to u, because cosine theta, that's du. So we can evaluate this indefinite integral with respect to now the variable u, and then it's just a matter of plugging sine theta back in once we're done. This is separable, right? We can make this into two separate integrals. This is the integral of 1 du minus the indefinite integral of u squared du. And now the antiderivative of 1, that's just u. And then we're going to have an arbitrary constant c, but I'll just add that in the end. And then indefinite integral of u squared, that's 1/3 u to the third, and then plus that arbitrary constant c. So that's the idea of u substitution. Makes it into an easier integral so that we don't have to just sit there and guess and check forever. Okay, there's a little bit of guess and checking to start, to figure out what that u and what that du is, but after that, it's much smoother sailing. Now I'm just plugging in sine theta back in for u. And there we go. We've reached the end here. Sine theta minus 1/3 sine theta, sine theta to the third power plus c. And if you checked your work, if you differentiated this, if we've done it right, you should be able to rewrite it a bit, and it should turn back into this after you combine.